Hey guys, welcome to CPM 3. This is Module 2, Lesson 2, and we are going to be graphing lines. So we've already learned two ways. We've learned the first way by making your little T-chart where you find 3 different points and plot them. And then the second way was your x-intercept and y-intercept. So both of those methods were in Module 1. So in Module 2, we're learning the third way, which is by the slope-intercept form. Now, we've kind of seen this a little bit. Your slope-intercept form is this y equals mx plus b form. And last lesson, we focused more on that slope portion. Now we're using all of this together, and we're going to use this to graph. So we know that the m means slope. The second portion of it is this constant that we didn't really use very much last time. This is your y-intercept. So when you graph this, you are first going to plot the y-intercept and then use your slope, which is your rise over run. Let me see if I can make this a little bit more legible. So first, plot y-intercept, and then second, use your slope, which is rise over run. Okay. So again, your slope is whatever with the x, your y-intercept is the constant, it's whatever not with the x. So in this first one here, let's go ahead and list out what's my slope, what's my y-intercept. So your slope is whatever with the x, so your slope here is 2 over 3. Your y-intercept is this point here, and so it is at -5, which if we write that as an ordered pair, since it's y-intercept, that means that -5 needs to go for the y, and you got 0 for your x. So, first thing you need to do is plot your y-intercept, so along your y-axis here, and let me actually zoom in some. Okay, so along your y-axis, plot 0, 5. So 0, -5. That's your first point. And then use your slope. Your slope is 2 over 3. So that is your rise over your run. So from this point, we're going up 1, 2, 3. And then running 1, nope, sorry, your rise is only 2. So I'm going up 1, 2, running 1, 2, 3. That's your next point. So notice I went up 2 because this is a positive 2, and then I went to the right 3 because this is a positive 3. So do that one more time. With all of these, you need 3 points total. So from this point that we just made, now rise and run one more time. So I'm going to rise 1, 2, run 1, 2, 3. So this is my line. Now I wish again that I can make these perfect. Okay, but that line keeps going. Again, make sure you got arrows on the ends of your lines. Now we kind of talked about this last lesson, but remember, it doesn't matter really what direction you go in. So we could change this 2 over 3 to become -2 over -3, because negative over negative gets me back to this positive. So from my y-intercept here, we could have went down 1, 2, and then ran 1, 2, 3, and then did it again, 1, 2, ran 1, 2, 3. Okay, so this line, this is why I wish I could have made it perfect. This line is supposed to go through this 2. Okay, just so you guys know. So that's just because I drew that line bad, but it should hit those points. So it doesn't matter which direction you go in with that rise or run. Just notice that this is a positive slope, and so we've got a positive line going here. So same thing on B. List out your information first. So my slope here is -4, and we need to make that into a fraction. So we've got -4 over 1. And again, I'm putting that negative in the top, but we can also make that +4 over -1. We're going to do both of those on this one again. My y-intercept, well, because on this one, your y-intercept is whatever this constant is, whatever this b is. Because I don't have anything, this is the same as this being +0. So my y-intercept then is 0, 0. If you don't have a constant, it's at 0, 0. So start at your y-intercept. So we're starting at the origin at 0, 0, and then use your slope. If I use this one first, that means my rise is -4. So that means I'm going down 4. So 1, 2, 3, 4, and then running a +1, which a +1 go to the positive numbers, is right here. We like 3 points. So from this point here, use your slope one more time. So go down 4, 1, 2, 3, 4, and then run a +1. Now, this is the exact same thing as this. So from my y-intercept here, this would be the same as going up +4, 1, 2, 3, 4, and then running a -1, which means I need to run to the negative numbers, so right here. We like 3 points, so let's say we didn't have these 2 points down here. So 1, 2, 3, 4, run a -1. So you get this somewhat straight line. If I could make this go through. It's a little bit better. So there's your straight line. Now you only need 3, and I keep putting 5, but I'm just wanting you to see that it does not matter what direction you go in. The big thing is this slope is a -4, and this line is going down, so it is negative. All right, so on C, same thing, but notice that on this one, it is not in your slope-intercept form. Right? Slope-intercept form means it's solved for y. This is not solved for y. So this goes back to what we did last lesson. You need to get y by itself. So the opposite of a positive 4x is to subtract 4x. So we get -7y equals, you can't put these together, but you do want your x before your constant. So -4x minus 14. Then divide by your -7. And notice I divided everything by -7, not just the 14 that it goes evenly into, but everything. So we get y equals, I can't reduce this, but negative over negative does become positive. So 4 over 7x, and then -14 minus 7 gives me a positive 2. So then list your stuff. My slope is what's in front of the x, so it's 4 over 7. And notice I'm not putting the x with it, right? It's just 4 over 7. And my y-intercept is this one here. And since it's your y-intercept, that means 2 goes in your y. So 0 here for your x. So plot your line. Start along. Start along your y-axis. So I'm going to go 0, 2, and then use your slope. My slope is 4 over 7, so this is my rise over my run. So since it's a positive 4, means I'm going up 4, and a positive 7 means I'm going to the right 7. So from this point, and you don't have to make these dots on your paper, okay? But you can't really see my pencil, so that's why I'm making the dots on here so you can kind of follow along how I'm counting. But we're going up 1, 2, 3, 4, running 1, 2, 3, 4, 5, 6, 7. Now we like 3 points, right? And so this is why it's so important that you can change that slope. If you notice here, from here I can go up 1, 2, 3, 4, but I can't run another 1, 2, 3, 4, 5, 6, 7. I don't have enough room there. So when that happens, that's why it's super crucial that you know that this is also the same as negative 4 over negative 7, right? Negative over negative equals positive. So now, from my original point here, now I can go negative 4 down and run a negative 7. So I'm going to go down 1, 2, 3, 4, run 1, 2, 3, 4, 5, 6, 7. So you have these lines or these dots in a straight line. That's a pretty good line, guys. So there is my line there. Notice that my slope here is positive, and this line is going up in a positive direction. Okay, so that's graphing your lines. So now that we kind of know what that y equals mx plus b form looks like, now we're going to write equations. Okay. It tells you here, the slope-intercept form can also be used to write equations of a line when we know its slope and y-intercept. So this is literally called slope-intercept form because why? It gives you two things. It gives you the slope of the line and the y-intercept of the line. So we need to write this equation of a line given that slope and its y-intercept. So we're going to put it in this form here. Your slope-intercept form is y equals mx plus b. Well, here they're telling you exactly what your m is, and they're telling you exactly what your b is. So just put in your m here and your b here. So in this first one, we've got y equals m. My m is negative 9. So negative 9x plus b. My b is 4. So plus 4. That's it. Okay, same thing on part B. Doesn't matter that this is a fraction. You're still just plugging it in. So we've got y equals, my m is that 5 over 2. So 5 over 2x, then plus b. Well, because my b is a negative 7, this will be a minus 7. Okay, and then c, we've got y equals my mx. Well, my m is 0. So I've got 0, 0x plus b. Again, it doesn't matter that that's a fraction, plus 1/2. Now this one can be simplified a little bit further. Because 0 times anything is 0, that just sort of all goes away. So my final answer on this one is y equals 1/2. Okay, and that's really the only time you can ever simplify is your slope is 0. All right, now we're going to move on to the second part of this lesson, and that is to use your point slope formula to write an equation. So they're not creative at all when they name these formulas. This is again called slope-intercept form because it tells you what? The slope and the y-intercept. This one here is called point slope form because it gives you what, or what do you use for it? You use one point or one ordered pair and the slope. So slope-intercept form, slope-intercept, slope, point slope form, slope, and a point. So this is another formula you are going to have to memorize. So along with this one is this point slope. Also need just your slope, that y2 minus y1 as well. So your point slope formula, you're not putting anything in for this x and this y. You are putting something in for this y1, this x1, and this slope. Again, the best thing to do is to label your things, so then all you have to do is substitute this in. Example 3 says to find, and let's go ahead and box this, sorry. Oops. Okay. So find the equation of a line passing through 2, 3. This is your ordered pair. So this is your x1, y1 with a slope of 4. Slope is your m. Write the equation in slope-intercept form. Slope-intercept form is your y equals mx plus b. So I'm just going to rewrite this formula real quick. Y minus y1 equals m times x minus x1. So just plug in your information. You have nothing labeled a y, so bring it down. Y minus, my y1 is 3. This equals my m. My m is 4. I have nothing labeled an x, so bring it down. Minus x1, my x1 is 2. So now that I'm putting this in slope-intercept form, that simply means solve it for y, right? This is y equals. So you're going to do the same 2 steps every single time you do this. First, you're going to distribute your slope to these parentheses. So we get y minus 3 equals 4 times x is 4x. 4 times a negative 2 is a negative 8. And then to get y by itself, whatever's over here, you're either adding or subtracting something over. In this case, because we're minusing 3, we're going to add 3 over. So I get y equals 4x, negative 8 plus 3 gives me negative 5. So that is my answer. Okay, we're going to be using this formula for like another 3 problems. So if you didn't get that, just hang tight, or you can rewind it and pause it. But let's go to the next page and let's try this formula again. So find the equation of a line with a slope of negative 2. So that is my m. That passes through negative 1, 5. So this is my x1, y1. So because I am given the slope and a point, we are using point slope formula. My point slope formula is y minus y1 equals m times x minus x1. So plug in your information. We have nothing labeled y, so bring it down. So y minus, my y1 is 5, equals my slope. My slope is negative 2. We have x, nothing is labeled x, so bring it down, minus my x1. My x1 is -1. So this is that same thing with that slope formula. This minus here gets brought down. But now my x1 is a -1. So we have minus a -1. Well, minus a negative becomes plus. So this is x plus 1. Same two steps every single time. Distribute first. So I get y minus 5 equals -2 times x is -2x. -2 times 1 is -2. I need to get y by itself since we're putting this in slope-intercept form. That means solve for y. Opposite of subtracting 5 is to add it over. So I get y equals -2x. -2 plus 5 gives me a plus 3. Now, on objective 4, we're using point-slope form to find the equation given 2 points. When you use this point-slope form, you need the slope. Well, this problem doesn't give me the slope. It says for an equation of a line through, or find the equation of a line through this point and this point, write the equation slope-intercept form. So I'm given 2 points, but no slope. Well, I can find slope with 2 points. So I'm going to use my slope formula. My slope formula is my y2 minus y1 over x2 minus x1. Label your ordered pairs. You've got x1, y1, x2, y2, so plug it into your formula. I'm actually going to go down instead. So y2 minus y1, so we got 1 minus 6. And then x2 minus x1 means 3 minus a -1, which makes that 3 plus 1. Oh, guys, I'm really sorry about this. This isn't going to come out evenly. So, I did this on your paper. So your note should say the right thing. This right here should be a -2. So when I do my minus x1, this needs to be minus a -2, so this will be plus 2 here. Okay, your paper should already have this -2. That was a typo on my part. Okay, so hopefully you're not completely confused. I'm just changing that one number. And again, your notes should already have that. Okay, so simplify. One minus 6 is -5. 3 plus 2 is 5. -5 divided by 5 is -1. So that's my slope. So now that I have a slope, use one of these points. It does not matter which point you use. Okay, now I'm making this line up. But let's say this line is like this. Whichever point you pick, it doesn't matter because both of those points are on that line. So you're going to get the same answer no matter which one you choose. So if I go with this one here, when I plug this into my y minus y1 equals m times x minus x1, we've got y minus, my y1 is 6, equals my slope is -1, and then x minus my y1, or my x1, sorry, my x1. So minus that -2 is going to become +2. So distribute, we get y minus 6 equals -x minus 2. And then your last step is to add this 6 over. So we get y equals -x plus 4. Now I wouldn't do this in class because I know it's boring, but I just want to prove a point that if I was to choose this point instead, I am still going to get to this answer here. So if I'm using this point with still the same slope, when I plug this into my y minus y1 equals m times x minus x1, we get y minus y1, well, my y1 is 1, equals my slope of -1, and then x minus x1, which is my x2, so -3. So we get y minus 1 equals -x plus 3. Add your 1 over, and you get y equals -x plus 4. So it does not matter what point you use, you still get to the exact same answer. So just pick a point. I usually pick the smaller of the two numbers, but it doesn't matter what you pick at the end of the day. Okay, example 6, let's try this again. Excuse me. It says to find the equation of a line passing through these 2 points, write the equation in slope-intercept form, and then graph. So again, I'm given 2 points but no slope, so we've got to find the slope first. So your slope is y2 minus y1 over x2 minus x1. Okay, make sure those y's are on top. That's the biggest mistake with that slope formula. Y on top, x on bottom. So label your points. This is your x1, y1, x2, y2. So y2 minus y1 is 5 minus a -4 minus a negative becomes a +4. x2 minus x1 is 0 minus a -7, so 0 plus 7. So simplify. 5 plus 4 gives me 9. 0 plus 7 gives me 7. I can't reduce that, so that is my slope. Now I'm going to show you a shortcut after we do this the long way. But now that I have my slope and 2 points, let's use them. So y minus y1 equals m times x minus x1. Use either point you want. I am going to pick this one here because of that very friendly 0. Zeros make everything easier. So we get y minus y1, my y1 is 5, equals my slope is this ugly fraction, and then x minus my x1, which is 0. So distribute. Y minus 5 equals 9 over 7x. You can either do nothing or plus 0, minus 0, whatever your heart desires about the 0. And then add this 5 over. And we get y equals 9 over 7x plus 5. So that is us writing this equation in slope-intercept form. Now, if you kind of know something, or notice something, not know something, notice something. My 0, 5, that is your y-intercept. If you look back over here, it tells you that your y-intercept is in the ordered pair of 0, comma, a number. So because I have 0, comma, a number, I really could have just used the slope and my y-intercept and plugged it in the same way that we did right here. Instead of them saying b equals 4, that would be the same as them saying 0, 4 instead of b is 4. So we could have just said, okay, that means we've got y equals my slope. My slope is 9 over 7 x plus b. My b is 5. So plus 5. Now you get the same answer, but this has no work. This has a lot of work. Okay, so that's just something to kind of be on the lookout for so you don't have to do all the extra work. But let's graph this. So we know the slope is 9 over 7 and my y-intercept is 0, 5. So start on your y-axis at 5. Use your slope. Now with this one, I can't really go up 9, right? Rise over run means up 9, positive 7. I can go positive 7 this way, but I don't have 9 to go up. So because of that, let's change this to our negative one. So this is the same as negative 9 over negative 7, right? Because negative over negative is positive. So from this point, we're going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, and then run 1, 2, 3, 4, 5, 6, 7. Guys, I'm sorry about all that coughing. We like 2 points. 2 points just does not fit on this graph. So this is an acceptable answer. And on MyMathLab, it only will allow you to do 2 points. Okay, but on your test, you need 3 points, and your test will allow 3 points on every graph. And one thing to I kind of want to show you guys is notice this point's negative 7, negative 4. This is at negative 7, negative 4. You've got 0, negative 5. This is at 0, negative 5. We basically plotted those 2 points using our slope-intercept form. So that's a lot of information on that one problem. Pause it, rewind it, let it soak in. We're moving on though. Find the equation of vertical and horizontal lines. So it says find the horizontal line through 4, 3. If you haven't memorized that x equals and y equals your vertical and horizontal line, that's really all you need to know. I, for one, don't have those memorized. So what I do is kind of roughly plot these points. So for 4, 3, if this is my x and y axis, I plot 4, 3. Now, here's what's confusing about plotting points in your slope. They go in opposite directions. When you plot, when you use your rise over run, let's say this is 4 over 3. This is your rise over run. So you're going up 4 over 3. But when this is an ordered pair, we're using OU, over side to side, before you go up or down. So this 4 means we're going to the right 4, 3 means we're going up 3. You move opposite with slope and points, and so you just have to memorize those. What's going to happen is a lot of people will either do one or the other. They'll always go up or down first, then side to side, like slope. Or they'll always go over side to side first, then up or down. But plotting points and slope move opposite directions first. Okay, so you have to memorize that. So roughly plot this point. If we're using OU, you're going over side to side, so +4, then up or down, so up 3. So I'm going 1, 2, 3, 4, up 1, 2, 3. So here's my point right here. So because this one wants a horizontal line, my horizontal line's going through here. And so what is this equation? Well, which axis is it touching? It's touching your y-axis. So you've got y equals, and where is it touching this y-axis at? At 1, 2, 3. That's supposed to be a little 3 right there. So y equals 3. So your horizontal line is whatever your y is. So then opposite, your vertical line is then whatever your x is. So in this one, it's x equals 3. But if you need to, graph it. And I always need to graph it myself. So here's your x and y axis. We're using OU again. So go over side to side before we go up or down. So 3 means +3 to the right. -2 means 2 down. So I'm going over 1, 2, 3, down 1, 2. Here's my point. It's a vertical line, so it's going through my graph right here. It is crossing my x-axis, and where is it crossing my x-axis at? Right here at 3. All right, and we're going to finish this exciting and amazing lesson with word problems. Example 8 says, in 1997, Window World Inc. had 50 employees. In 2012, the company had 85. Let X represent the number of years after 1997, and let Y represent the number of employees. So part A says, assume that the relationship between years after 1997 and the years and the number of employees is linear, and write an equation in slope-intercept form describing this relationship. Okay. Because we are letting Y represent the number of employees, we're letting X represent the number of years after 1997, we need to make some ordered pairs. So in this first one here, we got 1997 and 50. How many years after 1997 is 1997? That's 0. So we've got 0, 50. Okay, and again, we got that 0. We did 1997 minus 1997 to get 0. It's after that year. Don't use the year. Your second ordered pair says in 2012, we had 85 employees. So do the same thing. What is 2012 minus 1997? And we get 15. So my second ordered pair is 15, 85. Label your ordered pairs, because we've got to find the slope. So this is your x1, y1, x2, y2. Your slope formula is y2 minus y1 over x2 minus x1. So y2 minus y1 is 85 minus 50 over x2 minus x1. x2 is 15, x1 is 0. So simplify, we get 35 over 15, and I can reduce that. We can divide them both by 5. We're going to get 7 over 3 for my slope. Now that I have my slope and I have a point, we can use point slope formula, right? We can use that y minus y1 equals m times x minus x1. However, I have all the information I need. Because I have a 0 in for my x, this right here is my y-intercept, right? We went over this on that last one. Right here, if you got 0, comma, a number, that's your y-intercept. So I have my y-intercept, I have my slope, so just use your y equals mx plus b form. We have y equals mx plus b, because it says, write an equation in slope-intercept form. So plug in your information. So we've got y equals, my slope is 7 over 3. So 7 over 3x plus b, my b is 50. So that is my answer for part A. Now part B says use the equation to predict the number of employees in 2007. What is x going to equal if we're in 2007? Well, x represents the number of years after 1997. So subtract. What is 2007 minus 1997? We've got x to be 10. So use your equation to plug in a 10 for x and solve. So I have y equals 7 over 3 times 10 plus 50. So put this in your calculator. If you don't know how to put this in your calculator, come and see me and I'll show you, but you're going to use your ABC button. So you're going to do 7 ABC 3 times 10 plus 50. Put it all in there together. When you do that, you get 73.33 repeating as your answer. Now, because we're using this equation to predict the number of employees, I can't really have a third of an employee. Okay, and don't give me that crap about he could be missing both arms and a leg. Okay, even if he's missing both arms and a leg, you're still paying him full salary, so he's considered a full person. So we need to round this. So my answer, word problem, word answer, we need to say something like, and I'm very much so out of room here, but we need to say something like there's about 73 employees. Okay, but don't just say that. When did we have about 73 employees? In 2007. So there's my answer. All right, and last problem. Example 9. This this one's in here because this is a MyMathLab example of a problem. A lot of people get this one wrong for like the slightest little reason. So, example 9 says on a planet a rock is dropped from the top of a 400-foot cliff. After 1 second, the rock is traveling 26 feet per second. After 4 seconds, the rock is traveling 104 feet per second. Assume that the relations between time t and speed s is linear, and write an equation describing the relationship in slope-intercept form. Use the ordered pair of time comma speed. Okay. It's because I'm using time and then speed. make your ordered pairs. After 1 second, the rock was traveling 26 feet per second. So we get 1, 26. Then after 4 is traveling 104. Oh, whoops. So 4, 104. So label your ordered pairs. This is your X1, Y1, X2, Y2. Okay, sorry that's so light, but it is what it is. Okay, so use your slope formula here. We've got Y2 minus Y1 over X2 minus X1. So we get 78 on top, 3 on the bottom, and then that comes out to a nice and pretty 26. Now, unfortunately, this one does not have a y-intercept. I don't have a 0, a number. So on this one, we have to use point-slope formula. Point-slope formula is that y minus y1 equals m times x minus x1. Pick an ordered pair. I'm going to go with this one here because it is smaller numbers. So y minus y1 is y minus 26. My slope we found to be 26. And then x minus x1, my x1 is 1. So same 2 steps every single time. Distribute first. So 26 times x and 26 times negative 1. Then get y by itself. So we need to add 26 over. And so we get y equals 26x. That cancels out too, so just y equals 26x. Now this is where people mess up. This is the correct answer, right? And this is what you guys try to put in MyMathLab, and it always kicks it out and it says, no, that's not right. The reason it says it's not right is because it's wanting you to use t and s as your variables. So instead of typing this in, your y is speed, so your y, so you have s equals, then your time is x, so 26t. This is what you're typing in MyMathLab. Okay. So it's just a variable change. B says use the equation to determine the speed after 5 seconds. So easy enough. If my t equals 5, just plug that in for the t that we just found. So I've got s equals 26 times 5. So we get s is 130. Word problems need word answers. So, I don't know if I'll have room to write all this, but we need to say something like after 5 seconds, the rock is traveling. It's traveling 130, but 130 what? What unit are we in? We are not in miles per hour. We are in feet per second. So feet per second. Okay. So I don't know if I can box this without it looking worse, but this is my final answer for part B. All right, that's all I got. A lot of information, a lot of examples, a lot of things to think about. Rewind this video as you need to. Let me know if you have any questions.